So the purpose of this video is to give an overview of how to use GLADOS, including how to prepare your experiments and how to access the website and how to gather the data with the experiments that you've ran. This is covered in our documentation website over here as well under usage. As of recording this video, this has been updated and it has a more detailed guide including specific requirements for what our system supports, as well as specific steps that you need to take. So first, I'm going to go through an example experiment. This is a simple Python experiment that takes in two parameters, x and y, and it adds and subtracts the numbers as the results, and it writes it to a CSV. So normally writing an experiment would be very simple. However, there are some key features that are required in order to use GLaDOS. First off, we require parameters to be input through a .ini file. This can be seen here. This is an example. As you can see, I set the x and y parameters to their respective numerical values, and I put it under the default category. In order to take this in with your code, for Python experiments, we recommend using config parser. This is a Python library that reads files like these to be used in your code. Additionally, your code will also have to output to a CSV. In this example, we write to a CSV using the CSV library, and we have one specific CSV that we write to. And after you've made those adjustments to your code, confirm that you can run your code and see if it generates the correct CSV. As you can see, the output is put into a CSV respectively. This adds 1 and 5, and this subtracts 5 from 1. To actually submit it to the website to aggregate your data, you first need to create an account. I already have an account, so I'm going to just log in. And after you're logged in, you're sent to the dashboard. Now here, we need to make a new experiment. You can name it whatever you want. I'm just going to name it add nums example. You can give it a description if you would like. Personally, I will leave it blank. And we have a space for the trial result, which is where the CSV that you're writing to is named. So for this example, we're writing to add num result.csv. So I'm going to copy paste that in. And our system also supports outputting to multiple files. But with this experiment, since we're only using one output file, we can leave this field blank. Check whether you want to keep the logs or not. I'm going to keep it. Next, we need to input the parameters. So this is the main area that allows our system to run the experiment multiple times. We support integer parameters, floats, booleans, and strings. With this experiment, we're using two integer parameters. We're using x and y. We have 4 fields for integers, which is the default, the minimum, and the maximum, and the step. So to go from 1 to 10 with both x and y, you can specify the default to be 1, the minimum to be 1, max to be 10, and the step to be 1. And what this will do is it will go from 1 through 10 with x, and it'll keep y as 1, and then it'll go from 1 to 10 for y and keep x at its default value. Next, we also have a user-defined constants tab. If you have any constants or any parameters that you want to keep constant, let's say we had another constant like thing equals 2, and this thing was always going to be equal to, then we would set that over here. But in this simple experiment, we were only having x and y, and so we can leave this blank. We also have a post-processing tab. As of now, this is whether you want a scatter plot to be generated with your data or not. I'm gonna not select that, but if you want, you can specify the independent variable and the dependent variable to be used for the scatter plot. Finally, there's a confirmation tab, which specifies everything that you've put in so far. This is just to ensure that all the data that you want is correct and for debugging purposes. Finally, you can actually dispatch your experiment. I'm gonna put my addnums.py file and I can open it. And once I click dispatch, it'll take a while to start, and then it'll start spinning up, running the experiments until it is complete. Once it's complete, you can download the results. This is just a single CSV with your parameters on one side, the experiment number, and the results for each experiment. Now, additionally, you can view the system log. This is everything that's logged as the experiments are being ran. And if something goes wrong, it'll show up over here. Additionally, you can download the whole project zip, which includes all the logs for each experiment. And if you specified extra files, or if you specified that you wanted a scatter plot, it would also show up over here. Now, let's say you wanted to run the experiment again, but you wanted to change a few things. So to make this process faster, you could just copy the experiment, rename it to whatever you like, and make changes as you go through the different fields. So let's say I wanted to go from 1 to 100 for y instead. Then I can just change that really quickly, go through the whole process. Let's say I wanted a scatter plot this time, even though it doesn't really make sense for this experiment. And I'll do the same steps as before. Again, it'll go through the experiments, and once it's done, you can do whatever you want with the results. Finally, you can also rename the experiment after it's been done. So original, and if you press enter, it'll keep the name. If you escape, it'll cancel. And finally, you can also delete experiments, and that'll just remove it from your dashboard. More details are covered under the documentation website. And currently, the system supports Python, Java, and C experiments. So you can see we have an example that does the same thing in Java. It uses slightly different libraries, namely file writer to write the results. We also have a prop parser, which actually takes in the parameters from the config file. For C, we also have something similar. We use ini.h as our config parser, and we just write to a file for the output. We don't support third-party libraries that aren't included in a base Unix system. However, in the future, we plan on supporting experiments that require using third-party libraries.